Welcome, everyone. My name is Ricardo Camacho, Director of Regulatory Safety and Security Compliance at Parasoft. And thank you for joining us today on this webinar to go over the MISRA C 2012 Amendment 3, What You Need to Know. This is going to be a very informative and valuable presentation, especially coming from some very knowledgeable individuals. The presenters are Miroslav Zielinski, Director of Product Management. Say hello, Mirek.
Hello, everybody.
And Michał Rosenau, Software Project Lead and a member of the MISRA C and C++ Working Group.
Hello, it's a pleasure to be here.
Perfect. Okay, let's take a look at the agenda. Eric is going to set the stage of the presentation by giving us a glimpse overview of MISRA C 2012 and how the supporting MISRA extensions fit into the standard. This will actually give us the big picture. And then this will also nicely build the bridge into MISRA C 2012 Amendment 3, where Michał, our resident expert, will go into the details of the enhancements and updates in Amendment 3. We will then hand it back to Mirek, where he will deliver a live demo with a quick introduction. I'm also actually very excited about this presentation because we're very proud of the fact that our latest C++ test 2022.2, which was released in early December of last year, so just a month ago, already supports MISRA C 2012 Amendment 3. And on top of that, we are also supporting a draft version of MISRA C++ 22X. Anyway, after Mirek's demo, we will open things up for a live Q&A. Okay, let's get started. Handing it off to Mirek and Michał.
Thank you, Ricardo. So, our focus today is Amendment 3, but before we dive into details, I would like to start with a super quick overview of MISRA C 2012 supporting documents. MISRA C 2012 is by far the most popular selection of the coding guidelines used in the industry for developing safety and security critical applications. And we see it everywhere now, in all the verticals, starting from automotive, going through aerospace and defense, medical, ending on the industrial automation. The standard itself is already 10 years old, but it's continuously updated with various extensions. And when talking to our customers, we've noticed that organizations do not always have a complete understanding of the standard and meaning of these supplementary documents. So let's start with a very brief overview of these add-ons, and then I will give the stage to Michał to talk about what's new in Amendment 3. And throughout the years, MISRA C 2012 was augmented with the following additions. There were 3 amendments, 2 technical corrigenda, 3 addendums, 1 document with permits, and 2 documents about the compliance process and reporting. Each of these documents extend the core standard. In our session today, we don't have enough time to dive deeper into this document's content, so I will only explain their primary purpose. Let's start with the technical corrigendum documents. They are released to fix issues reported by the standard adopters. Their primary purpose is to provide additional clarifications for the guidelines descriptions, additional exceptions for rules and directives, and in a few cases, changes in the guidelines categories. So we are talking here about minor fixes in the guidelines text, as well as essential clarifications related to, for example, guideline application, like an explanation of whether a rule applies to variadic functions or not. So far, for MISRA C 2012, we had 2 corrigendums released. The last one was published in March earlier this year. The content of the technical corrigendums is typically integrated into subsequent revisions of the standard. Then we have MISRA C 2012 addendums. Addendums provide mapping between MISRA C 2012 and other coding guidelines. So far there were 3 addendums released. The first one contained mapping to MISRA C 2004, the second contained mapping to Secure C, and the third one was focused on the Cert C. Addendums are very useful when you have a business requirement to comply with more than one coding standard, or when you're migrating your compliance from MISRA C 2004 to MISRA C 2012. With addendums, it's easier to understand the delta between standards and decide whether additional guidelines should be added or whether MISRA C 2012 alone is sufficient. And then we have MISRA permits. MISRA permits are very helpful when deviating from the standard. The MISRA permits is a document containing common use cases, say typical code constructs in the context of specific rules, when deviating from the standard may be acceptable. MISRA permits are not blank permissions to deviate. The final decision must be always made in the context of the specific project. Deviation permits shall be evaluated and negotiated preferably at the beginning of the project. MISRA permits provide a lot of information regarding deviation reason, background, and requirements. This predefined information highly simplifies creating deviation reports and saves a lot of time and money in the compliance process. Users can of course create their own permits, and in many projects we've seen MISRA permits used as golden patterns for creating local deviation permits. Another supplementary document is the MISRA compliance. The MISRA compliance document clarifies or defines what does it mean to comply with MISRA. It lists the fundamental elements of the compliance process. It defines the deviation procedure. It provides the guidance for potential guidelines recategorization. And it gives examples of reports that should be compiled in order to claim MISRA compliance. The important note here is that starting from Amendment 2, the guidance provided in the compliance document is obligatory for MISRA C 2012. And finally, we have amendments. Amendments typically substantially update the standard, including new rules and directives. So far, we have had 3 amendments released. Amendment 1 provides additional guidelines for security. Amendment 2 was an initial attempt to extend the standard for the newer versions of the C language. And Amendment 3 continues this focus, bringing even more guidance to enable the safe use of the modern C language features. And here is where I stop and pass over to Michał to give you a more thorough overview of the Amendment 3.
Okay, thank you, Mirek. So now let's focus on the latest MISRA publication, Amendment 3 to the MISRA C 2012 coding guidelines. As it was already mentioned, the main subject of this document is to provide guidance on the safe use of the new language features introduced in C11. It is a continuation of the work started by the Amendment 2 in 2020. On the other hand, it's worth to mention that there are still some uncovered features like threads and atomics, which are going to be handled by the subsequent amendment. So now let's dive into the contents of this new document. So what's new in Amendment 3? The main subject of this document is the features introduced to the language by C11. The amendment allows to use the no-return function specifier, object alignment specification, and type generic expressions, provided that all the new MISRA rules related to these features are being followed. Additionally, Amendment 3 restricts the use of the language and library features defined by the C standard as obsolescent. Note that such features are usually superseded by better alternatives or are considered to exhibit undesirable behavior. Finally, Amendment 3 provides additional guidance on the use of some of the older features of the C standard, such as floating point expressions, complex numbers, type generic math macros, and others. Amendment 3 brings 1 new directive and 23 new rules, which means that currently we have the total number of 199 guidelines in MISRA C. 3 existing directives and 15 rules have been amended by this document. And also the essential type model has been updated to include the notion of the complex floating point types. Now, if we look at the rule categories, Amendment 3 adds 3 new mandatory rules, which must be followed in order to claim the project to be MISRA compliant. So it means we currently have 19 mandatory rules in MISRA C. The document also adds 12 new required rules that may be violated when supported by appropriate deviation procedure, and 8 new advisory rules that do not require formal deviation procedure for violations. So now let's have a look at some of the new MISRA rules. One of the features introduced by C11 is the no-return function specifier, which annotates a function as never returning. There are 3 new rules related to this feature in the new MISRA document. One of them is a mandatory rule 17.9, which states that a function declared with a no-return function specifier shall not return to its caller. This is because returning from a function declared as no return results in the undefined behavior. So here you can see the simple non-compliant code example where a function contains a loop that's supposed to be infinite, but which contains a break statement that may result in returning from a function. To make the function compliant, we may make the program terminate by calling exit function from the standard library instead of simply breaking the loop execution. Another feature introduced by C11 is an alignment specification. The amendment brings 3 new rules covering this topic. One of them is the new required rule 8.15, which states that all declarations of an object with an explicit alignment specification shall specify the same alignment. And this is to avoid potential undefined behavior, which occurs when 2 declarations of the same object have conflicting alignment specifications. But MISRA rule goes beyond the undefined behavior itself and requires that all such declarations use the alignment specifications that are lexically identical after macro expansion. And this is to ensure consistency and to avoid potential portability problems. The non-compliant code example shows 2 declarations of the same object, one with explicit alignment specification and one without. To make the code compliant, the same alignment specification needs to be used in all declarations, or it needs to be consistently omitted in all cases. The next feature introduced by the C11 is the generic selection expression. Here, 8 new guidelines have been added to cover this subject, 4 required and 4 advisory rules. As an example, let's look at required rule 23.6, which states that the controlling expression of a generic selection shall have an essential type that matches its standard type. And this is to make sure the association selected by the generic selection is consistent with the essential type model of the MISRA C guidelines. In this non-compliant example, the standard type of the character constant is int, which means that the int association is selected, while the essential type of the controlling expression is char. So if the actual intention is to have the int association selected, the character constant may be converted to an int using a cast, which makes the developer's intention explicit. The Amendment 3 introduces also some additional restrictions and recommendations on the use of the real and complex floating point expressions. There is one new directive which requires developers to mitigate the possible generation of infinities and not a number values when performing calculations using floating point numbers. A new document introduces also the concept of the essentially complex floating type category and updates the rules from the essential type model section of the MISRA C guidelines to restrict incorrect use of the complex floating point type expressions. It also gives some additional restrictions on the use of such expressions. For example, it disallows comparing them for equality, which may result in unpredictable behavior due to the nature of the floating point types. And finally, Amendment 3 adds 3 more rules covering different aspects of the C language, which apply also to the older language versions. This includes restricting use of the features defined as obsolescent by the standard, and some of the other areas: bit fields, integer constant macros, function identifiers, function type qualifiers, object lifetime, type generic macros, and use of the random number functions from the standard library. 2 of these additional rules, 7.5 and 21.22, are mandatory, because violating them always results in the undefined behavior. So now that we know better the contents of the Amendment 3, questions arise. Is this amendment important to me? And shall I consider adopting it in my project, which is currently developed using MISRA C 2012 guidelines? Well, since the title of the document talks about the new C11 and C18 features, the answer surely is yes if you develop your code using C11 or C18. But even if you still write your code with conformance to C90 or C99, Amendment 3 is still relevant, as 10 out of 24 new guidelines apply to C99, and 6 of them apply also to C90. Please note also that the new MISRA document improves several existing guidelines which you already use. So the answer for the question is yes, also if you still use C90 or C99 in your project. So with that, I will pass back to Mirek.
Thank you, Michał, for a great overview. So, before we see the demo, let's think for a moment what are the essential requirements for the MISRA compliance solution. If we want to enforce compliance with MISRA, the first thing is that the tool should provide 100% coverage for the standard. If we also need to comply with functional safety standard such as ISO 26262, we must qualify the tool. TÜV certification, if available for the tool, highly simplifies this process. And finally, a very important aspect is the close integrations with the modern development workflows. Most of the teams these days use some kind of CI platform, and teams don't want to change their workflows. They expect that tool will seamlessly plug into their system. And this is why it's so important that static analysis tool can be easily integrated into the modern development workflows and platforms. In our demonstration, we will see how you can add MISRA C 2012 compliance to your CI-based development process. We will see a simple scenario with developer working on the code in the feature branch. For the demonstration, we'll use a Linux workstation with VS Code and Parasoft C++ test, and GitHub with workflow that includes MISRA C 2012 quality gate. During the demonstration, we'll go through the following steps: creating some new code in the feature branch, running a quick pre-commit static analysis session focused on the most obvious problems, creating a pull request in GitHub which will trigger a pipeline with complete MISRA quality gate, and updating the code to meet the pull request's quality gate requirements. So let's switch to my development workstation. I'm using VS Code and I already have a local clone of my GitHub repository here. I'm working on a feature branch trying to implement new functionality for my system. My development toolchain is containerized. So the compiler, build tools, and Parasoft C++ test static analyzer are all in my container. It takes me only a few seconds to get ready for development. My GitHub pipeline uses the same container. So let's say that my project requires MISRA compliance. My compliance process includes two steps: quick local scans with limited selection of MISRA checkers focused on the most critical problems, and complete enforcement of MISRA C 2012 guidelines integrated with the GitHub pull request workflow. So let me pretend now that I'm doing something useful, and I will add some new code to my feature branch. Let's say I need to implement a new function. Okay, I'm ready with my new code, and before I commit, I will run a quick local scan for MISRA compliance. Please note here that, as I mentioned earlier, my entire toolchain is containerized. Now Parasoft C++ test analyzes my code, and in a few seconds we will have results. Clearly, my new code is not MISRA compliant. We have one problem reported for our new code, and this is a violation of MISRA rule 18.9. Here, in this line, the getSensor function returns a struct, and its array member is then used as a value. This is definitely not a good practice. We can open the rule documentation if we need more information to understand the problem better. In the documentation, we can find a thorough description and examples showing incorrect and corrected code. In the references, we can see that this rule is introduced with MISRA C 2012 Amendment 3. Alright, let's fix the problem. We will need to slightly modify the function. And now we're ready to push our changes to GitHub. Obviously, we're interested in merging our new code with main branch. So let's go to GitHub and create a pull request. Our pull request triggered the pipeline with C++ test MISRA C 2012 quality gate. In our local scans, only the most important rules are included to assure minimal delays. In pull requests, we are enforcing compliance with all the MISRA rules. So let's give it a second to finish, and our pipeline is done. We can clearly see that we are not yet ready to merge our code because additional violations were found. Let's drill down for details. C++ test static analysis results are integrated with GitHub's pull requests. Here, we can see one additional finding reported. We can click Show More Details to investigate the problem. This issue is not very complicated. It seems that our main loop function never returns, and it is not declared as non-returning. That's another example of a new rule introduced with Amendment 3. If we need, we can see this issue in the full context by opening the file. Indeed, the main loop function never returns, which is expected. So this is an easy fix. We just need to declare main loop function as non-returning. For this kind of easy issues, I can edit the code directly in GitHub. But I can also go back to my development environment and download pipeline results to my VS Code. Now it's very convenient for me to fix the problem and push the code back to GitHub. The push operation will trigger the pipeline again with the MISRA quality gate. We are expecting a clear run now since we fixed the only problem. And indeed, our quality gate is now opened and we are free to merge our new code. And this concludes our demonstration. Ricardo, passing to you for a quick summary.
Thank you, Mirek and Michał. That was actually a really great presentation, as always. And to recap, we got a bird's eye view of MISRA C 2012 and how the extensions such as the technical addendums, amendments, and corrigendum tie into the standard. Michał then went into the technical details of Amendment 3, such as the restrictions on the use of obsolescent language features, no return function specifier, and actually some other guidelines. But very important to understand is that the latest standard continues to be relevant to those organizations using pre-C11 coding languages such as C90 and C99. And our customers or prospects can take immediate benefit of the updates to MISRA C 2012 Amendment 3 because we already provide complete coverage in our C++ test product offering. And Mirek demonstrated this in his the demo. And the fact is that not only can you integrate our static analysis engine solution into the developer's code editor or IDE, but as Mirek demonstrated, they can seamlessly be integrated into your build process or modern development workflow using GitHub. And just FYI, integrations with GitLab and Azure DevOps also exist. Okay, let me suggest a few actions to perform here, and then I'm going to open it up for Q&A. If you're a customer and want to take advantage of the latest Amendment 3 update to MISRA C 2012, please visit the Parasoft customer portal where you can download the latest C++ test 2022.2 release. If you want to learn more about C++ test, please request a custom in-depth demo. We're always happy to provide those. And I've also placed a QR code just there for you. You can also visit our website, parasoft.com, and navigate to the C++ test product page where you will find a Try Parasoft button. Also, if you have any questions that come up after this presentation, please send us an email at info@parasoft.com. You can also find us and follow us on Twitter, Facebook, and LinkedIn. Okay, I'm going to open things up for Q&A. First question actually came in. It was, will the recording be made available? Absolutely. Recording will be sent to you. So if you missed it or any of your colleagues, please, you'll have that available. Actually, we have some good questions here. I'm going to start with the one that actually is very similar to the one I had in December when we released our 2022.6 product. Is Amendment 3 mandatory? So we started cleaning up our code for MISRA C 2012 compliance, and we are very close to achieving our goal. Can we now say that we are MISRA C 2012 compliant if our compliance scans do not include Amendment 3 guidelines? So this is to Mirek or Michał.
Yes, so it's Michał here. Yes, that's a very good question. So firstly, we need to understand that Amendment 3 was introduced for a reason. So it updates the standard with our latest knowledge about the potential problems of using C language. So therefore, we we can't simply ignore it just because we started our work without it. On the other hand, the existence of the new amendment itself does not automatically invalidate compliance for all the previous projects. So if you have a business requirement to comply with MISRA C 2012, I think you can still say you are compliant, but you need to make it clearly visible and that your compliance definition does not include the notion of the amendment 3. And then you probably should include amendment 3 in your process as soon as possible.
Okay, wonderful. Another question. You mentioned Amendment 4. What is coming?
Yeah, so let me answer that as well. Without going into too many details, right now we can say that the following amendment document will be focused on providing guidance for the remaining C11, C18 language features. And yeah, there are two big topics left, threads and atomics, and they will be covered.
Okay. Let's see. Another question here. How can I access Amendment 3? Do I need to purchase it or is it publicly available?
Okay, that's an easy one. I'll handle it. This is Mirek. All amendments are publicly available, free of charge, and you can download these documents directly from the MISRA website.
Okay, that's really easy. I've actually done it many times. Let's see. Another one is I'm already using MISRA checker for my project. What's the best strategy to introduce Amendment 3?
Well, first you need to update your tool to support Amendment 3. And there are two things here as we covered this during the session. First is support for the new rules introduced in the Amendment 3. And second is changes in pre-existing rules. And once you have tool that supports entire Amendment 3, you can run new and updated rules to see how many violations you have in your code. And if you have many new problems, you can consider progressively enabling new rules to avoid flooding your developers with too many new problems.
Mm-hmm. Yep. Okay, let's see. The next question is my project is C99. If I apply Amendment 3 to the project, will I get any violations that are related to C11 or C18 features?
Yeah, that's interesting question. So generally, no, because the new rules related to C11, C18 will generally trigger only if those new language features are used. But there is one exception. It is related to the rule which requires no return function specifier to be used for non-returning functions. So actually it's the lack of the no return keyword that can potentially trigger an issue, possibly on C99 or older code. But a good static analysis tool shall recognize that the analyzed code is not C11 and shall stay quiet because the rule is defined as non-applicable for the older version of the standard than C11.
Okay, great. So actually, there's one last question I'm seeing here, and this it says, does your C++ test tool handle CWE, CertC, and CertC++? What rules from MISRA are still not covered by the tool and require manual analysis?
All right, so we have like two questions here regarding support for CWE, CertC, and CertC++. The answer is yes, absolutely. We support CertC, CertC++, and we have also static analysis checkers for CWEs. We support top 25 and on the cusp selections. And regarding coverage for MISRA, I'm guessing that this is about question is about our subject of this webinar, MISRA C 2012. And the answer is that we cover basically 100% of the standard. I think there is one or two exceptions for the guidelines that are not enforceable with static analysis. There is directive, I believe, from the top of my memory, 3.1, which says that all code shall be traceable to documented requirements. So that's not really enforceable with a static analysis. And that's really it, I believe. Other guidelines are supported with static analysis checkers.
Mm-hmm. Yeah, and and I recommend that folks try out our product to request a custom demo, and that would help answer many questions if you have any. And actually, we don't have any other questions left, so I want to thank Michał and Mirek for a fantastic, informative presentation. And don't forget, folks, to send us an email at info@parasoft.com if you have additional questions, or visit our website. There, we have lots of other collateral content and recordings, ebooks, and so forth. I think you'll find very valuable to help you in your projects and research. Okay, well, Mirek and Michał, you might want to say au revoir. Any last words?
Thank you very much.
Yes, thank you.
All right, folks. Thanks. Have a great day. Bye-bye.
Bye.
Bye.